Here's number one from the Bluebook test preview for both Calc AB and BC. So they say on a certain weekday, the rate at which vehicles cross a bridge is modeled by the differentiable function r on the interval 0 to 12. R of t has units of vehicles per hour. Time is measured in hours since 7 a.m. So 7 a.m. is the t equals 0 location. Values of r of t at selected values of t are given in the table. So we're asked to use data in the table to approximate r prime of 5. Show the computations that we use units, and explain the meaning within context. This is very typical of a table of values problem. We don't have any information about time 5, but we do see that time 5 is central to the interval 4 to 6. Sometimes the phrasing of a task like this is even going to say, use the average rate of change of r to estimate r prime of 5. Average rate of change is a slope calculation. Now, the one thing that I would worry about happening, I've seen this happen to my students a decent amount, would be in the table, the values of the horizontal axis variable are typically in the top row, and the vertical axis variable are in the bottom row. When you do a slope calculation, an average rate of change calculation, and we want to do it on the interval where 5 is smack dab in the middle, we need to make sure we subtract the y-axis values divided by the corresponding x-axis values. So that ends up being negative 216. These units in the numerator, vehicles per hour. In the denominator, that's a difference of hours, so vehicles per hour per hour. When you interpret a derivative's value, you're always going to need to make sure you acknowledge the input. So this is at t equals 5, an instantaneous rate of change. At t equals 5, the rate that the vehicles cross the bridge is decreasing by approximately 216 vehicles per hour per hour. There's a little bit of flexibility in the explanation. One thing that I could have gotten into a little bit of trouble with here is if I would have used the word decreasing and included the negative here. I've used a word that indicates that the rate is going down, but I've also used a sign that indicates another direction change. So if you use the word decreasing, make sure you don't attach the negative to your number. Alternatively, I could have said the rate at which vehicles cross the bridge is changing by approximately negative 216 vehicles per hour per hour. Part B, also very typical of what you normally are asked to do when a problem presents a table of values. So we're asked to use a midpoint Riemann sum, 3 subintervals of equal length, indicated by the data in the table to approximate the value of this definite integral. We're also asked to indicate units of measure. Let's talk about units of measure first. So if I do the integral of r of t with respect to t, r of t has units of vehicles per hour. This differential, dt in this case, has the same units as the horizontal axis variable have. So when I take the product of vehicles per hour and hours, the hours cancel and I'm left with units of vehicles. Now the Riemann sum says 3 subintervals of equal length. Well, if my interval goes from 0 to 12, my equal length subintervals are going to be 0 to 4, 4 to 8, and then 8 to 12. So each of my subintervals is going to have a width of 4 units. Now the height of each of my rectangles is going to have to come from the midpoint of each of those subintervals. Well, if my interval is 0 to 4, the midpoint is 2, I'm going to use this for the first height. My next interval is 4 to 8. Midpoint would be 6, therefore I'm going to use this for my next height. My last interval would be 8 to 12. Midpoint is 10. I'm using that for my final height. I can pop that into the calculator and I get 34,596 vehicles. Now it goes on to say that on a certain weekend day, the rate that vehicles cross the bridge is modeled by the function h. So h is given here, and it holds on the interval 0 to 17. H is measured in vehicles per hour. T is still being measured in time since 7 a.m. Hours since 7 a.m., I should say. According to this model, what is the average number of vehicles crossing the bridge per hour? H of t has units of vehicles per hour. We want the average number of vehicles crossing the bridge per hour, meaning we want the average value of this function h of t on the interval 0 to 12. So all I'm doing here is I'm breaking out the function, the calculation for the average value of the function h of t on the interval 0 to 12. So 1 over the difference between the endpoints of the interval that I want to do this calculation across times the definite integral of that function that I want the average value of across the corresponding interval. This is a calculator problem. You could fire up Desmos. You could go to your handheld with your numerical integration option and end up with 2,452. I didn't include units here. It doesn't explicitly ask for them. If you tacked on vehicles per hour, that would be fine. I have the tendency to say if the problem doesn't ask for units, don't list them, because if you goof those, you've given evidence that you maybe didn't fully understand what was going on within the problem, and they weren't necessary anyhow. Last part of this. On the interval 12 to 17, L of t is the linear approximation for the function h from part C at time 12. That's a better model for the rate at which vehicles cross the bridge on the weekend day. So we're wanting to use L of t to find the time on the interval 12 to 17 when the rate of vehicles crossing the bridge is exactly 2,000 vehicles per hour. Show the work that leads to your answer. So what I'm going to start by doing is I'm going to start by finding my linear approximation, or my tangent line, based at t equals 12. So this is a tangent line to the function h. So I do need to base it at 12, meaning my slope for my tangent line is going to be h prime of 12. So I again use my numerical derivative option. I guess I didn't use that in any other part here, but it's a calculator question, so you could use Desmos to find the numerical value of the derivative of that function h. You could use your handheld to do that. And I'm building a point slope form for the equation of my tangent line right here. Slope is negative 216. The time that I'm basing my tangent line at is 12. In the y value, so the actual value of h, so simply putting 12 in place of the t's in the formula for h of t gives me 2596. So here is my equation for my tangent line. I want to know when my y value is exactly 2000. So I'm putting 2000 in place of y, and I'm solving this equation for t. You can solve this algebraically. It is a calculator question, so you could solve it graphically. You do need to make sure you have 3 digits of accuracy beyond your decimal for your final answer, and that ends up giving you a result of 14.579.